Okay, so when we were solving these systems of linear equations yesterday, these were our 5 main steps that we had to solving it. I think I may, yep, I believe this is the way that I had them. So 1, find a variable. 2, eliminate. Step 2 was to find and eliminate equation. Step 3 was to eliminate that variable. Or at least the chosen variable. Step 4 was to repeat. Steps 1 and 3. And step number 5 is to solve backwards. So you don't need to rewrite these down if you already have them down, because we had these all written down yesterday. And we're using these steps to be able to solve these 3 variable systems of equations. Because we're wanting to go from 3 equations with 3 variables to 2 equations with 2 and 1 with 1. Or solve or eliminate down so we only have 1 variable, and then solve for the rest. Solve for the other ones that we have. So this here is going to be the first equation that we look at today. So here we have x minus 2y plus z is equal to negative 11. 3x plus 2y minus z is equal to 7. Negative x plus 2y plus 4z is equal to negative 9. So the first thing we need to do is we need to pick a variable to eliminate from all 3. Which variable do we want to eliminate first? Y. I would agree. Because when I first looked at this, especially this morning, last hour, I was kind of leaning towards x and z. Because we do have, in the first equation, they both have 1. In the last equation, the middle equation, z is 1, and in the last one, x is 1. But then I noticed that the y's are 2y, 2y, and 2y. They're all the same. So if I have one that's all the same, might as well use it. Now, which equation do we want to be the eliminator equation? Or does it really matter? It doesn't really matter. We just need to pick one. Which one do we want to use? So we use this as the eliminator equation. So we can go on and write the other 2 equations down. Now, since the value in front of y in our eliminator equation is already the same as the other 2, we can go on and put it down. Since we don't have to do anything to y to make them be the same, we can just rewrite them down. Now let's look at the left equations first. So we want to combine them with addition or subtraction so that y cancels out completely or becomes 0. So would we add or subtract? Would we add these 2 together or subtract them? What would it be? Add. The signs are opposite, we add. When the signs are opposite, we're going to add. I'll choose this color. So we're going to add these together. So x plus 3x is 4x. Negative 2y plus 2y is 0. That's what we wanted. We wanted those to cancel. That's what our job or our goal for this was. And z plus negative z is 0, is equal to negative 4. So wait a minute. So I'm just left with 4x equals negative 4, yes? Yeah, we would divide both sides by 4. We're just going to solve it for x. So we have one of our solutions. That's nicer than what we had yesterday. Because yesterday we didn't end up with that after one step. We normally had two variables. So that works out just fine. So if the other equations, when we combine them, give us two variables, then we're good to go. We can plug a value of x in and solve. So looking at this here, would we add or subtract? Subtract, because the signs in front of y are the same. If they're the same, we're going to subtract. Well, negative x minus 3x is going to be negative 4x. 2y minus 2y is 0, just like we wanted. And now 4z minus negative z. Well, the negative and negative would make a positive. So 4z plus z is plus 5z is equal to negative 16. So here I have an equation with two variables. But do I already know one of them? Yeah, I know x is equal to negative 1. So I don't have to repeat steps 1 and 2 because I have one of them and I can start solving backwards. So this worked out a little bit better than the ones previously. So we can say 4 times negative 1 plus 5z is equal to negative 16. 4 times negative 1 is 4. Plus 5z is equal to negative 16. Minus 4 from both sides. These will simplify, leaving me with 5z is equal to divide both sides by 5, and z is equal to negative 4. Any questions on this here? Okay. So negative 4. So what are the only thing we're missing? Why? Erase this here to make more space. Now we just need to plug these two values into one of the three equations to solve for the value of y. Which one do we want to use? So we can use the bottom one. So x is negative 1. So we have negative 1 plus 2y plus 4 times negative 4 is equal to negative 9. And now we just need to solve for the value of y. Well, our negative 1 is just going to be 1 plus 2y. 4 times negative 4 would be negative 16 is equal to negative 9. 2y. 1 minus 16 would be negative 15. At this point here, we can add 15 to both sides because those will cancel. Telling us that 2y is equal to tells us y is equal to 3. So negative 1, 3, negative 4 is the solution for this system of linear equations. Yes, sir. This one? 1 and negative 16? Yeah, we combined like terms. Any other questions? All right, let's look at the next one here. Which variable do we want to eliminate out of all three? Z? Are we good with Z? Because X, if I choose X, well, we have 4X and 2X, Y, 4Y, 2Y, Z, 4Z, and Z. So we have two equations for Z that already match up. We don't have to do anything with. Must work. I'm okay with. Which one do we want to use as the eliminator equation? X plus Y minus Z. So eliminating any of these three variables, which one would I not use as the eliminator equation? The middle. 4X plus 4Y minus 4Z. Because if I use that for any of them, I'm going to have to not only increase it, most likely, and increase the other two. Because to get 4X and 3X to be the same, well, the first number that works out is 12. So I'm going to multiply both equations to get X to be the same. Because I need those to be the same number in front of them so that they cancel out. And the first number, that 4 and 3, I can make both of them be the same as 12. So it's going to cause more work. So we can write the other two equations down. 4X plus 4Y minus 4Z is equal to negative 2. And 3X plus 2Y plus Z is equal to 0. Well, we've said for this one here, Z is already the same. We don't have to do anything for this equation here to get the Z's to have the same number in front of them, so we can go on and put it down. I'll keep using this color. So let's go on and take care of this one first, and then we can focus on the other equation next. Would we add these two together or subtract them? So subtracting, because we want the Z's to cancel out, yes? And Z minus negative Z would be? A negative and negative make a what? So that'd be Z plus Z, which is 2Z. We want it to be what? 0, yes? So, okay, so we wouldn't subtract, we would add, because Z plus negative Z or Z minus Z, 1 minus 1 is 0. That's what we want. So let's go on and add. 3X plus X is 2Y plus Y is plus 3Y. Z plus negative Z is 0, just like we wanted. And it's equal to negative 1. 0 plus negative 1, or 0 minus 1, is negative 1. Okay. Now again, like I said yesterday, I would write this off to the side. Don't write it directly underneath. Because again, we still have work to do. Because we're still going to be working down. Now, what do I need to multiply this entire equation by so that the Z's are the same? 4. Because we have 4Z, so I need to multiply both sides by 4. So we'll distribute the 4 through. 4 times X is 4X plus 4 times Y is 4Y. 4 times negative Z would be negative 4Z. And 4 times negative 1 would be negative 4. So we multiplied the entire equation by 4. We scaled it up by a factor of 4. Any questions on how we got this equation here? Now we want to put it right under the other equation.
Is that not all just going to cancel out?
It looks like it. But let's go on and do the operation just to make sure. because there's been times I was convinced, I'm like, okay, they're lining up perfectly, they're going to cancel out, and then when I did the operation, they didn't. But it's good to just check and make sure. Now, since the vortices have the same sign, we would subtract. And I have a feeling you're right. We're going to have a lot of things canceling out because 4x minus 4x is 4y minus 4y. 4z minus negative 4z, or negative 4z plus 4z is negative and negative make a positive. Well, negative 2 plus 4 is no solution. And again, like we saw yesterday, if we get a false statement at any point, it's going to be no solution because it's saying that two of those planes are parallel to each other. They do not intersect. They do not cross. Any questions on this here? This is the last one we're going to look at today. So we need to pick a variable to eliminate. It'd help us solve the problem. Okay. Right, we can use y to eliminate out. Since they're all the same number in front, 1, 1, 1. That means I don't have to change a thing. I don't have to multiply any of the equations by a factor to get them to be the same. Well, which equation do we want to use as the eliminator equation? Yeah, we can use this here. Eliminator equation. So we'll write the other two down. X plus y plus z is equal to 8. And we have x minus y plus z is equal to 8. Now, as we said, since the other equation since y is already the same, in all of these here, we can just write it on down because I don't have to change y at all since the values of y are going to be the same. They are going to cancel out. So let's look at the one on the left. What do I need to do first? We need to subtract because the signs in front of y are the same. So we will subtract. X minus 2x is negative x. Y minus y is 0. And z minus negative 2z is negative z is equal to negative 8. What about this one over here? What would we do? Signs in front of y are opposite, so we would add these together. X plus 2x is 3x. Negative y plus y is 0. 1 minus 1 is 0. 2z plus z is plus 3z is equal to 8 plus 16 would be 24. Okay, now we need to repeat steps 1 and 3. We need to pick a variable to eliminate. Which one do we want to eliminate? Z. Now we always want to go up. If we're scaling, we don't want to scale things down. So we're not going to use this 3x plus 3z equals 24 as the one to change. Because I'm not going to change 3z to 1z. It's going to be easier to change 1z to 3z. It's easier to change it up or scale it up than it is to scale it down. So that means with this other equation, we're going to multiply everything by 3 so that the values in front of z will be the same. They'll both be 3. So we can do 3 times negative x will be negative 3x. 3 times negative z will be negative 3. Z is equal to negative 24. Any questions on this here so far? Would we add or subtract these? Add because the signs are opposite. So 3x plus negative 3x. 3x minus 3x. 0. 3z minus 3z. 24 minus 24. Is that a true statement? So that tells me I have infinitely many solutions. There's infinitely many solutions for this here. Now that's all I'm going to have you do for this here, but I'm going to go on and show you how we can get the equation that would define the solution set. And what we would do for this here is we would start out by picking either x or z, a variable a value of a. Now, I'll just pick x because I did that first hour or the first class. And what we'll do is we'll come back here and replace z with negative, or x with negative a. Move this over. So we're going to say that x is a. And then I go back up here, I replace x with a. So we have negative a plus or minus z equals negative 8. And then I'm going to solve this for z. So we have a minus 8. Divide everything by negative 1, which tells us z is equal to negative a plus 8. And really all I'm doing with this here is I'm going back and just solving back through given a value a. And I just arbitrarily picked a just as a variable to hold a place. And then once we do this, and again I know I'm erasing a lot, is we can come back up to the top. I'll take, come on, with me. I already know it's infinitely many solutions. So. And what I'm going to do is now plug these two values in for one of these two equations. I'll take the top one. So a plus y plus negative a plus 8 is equal to 8. So we'll have a plus y minus a plus 8 is equal to 8. Well, a minus a will cancel, leaving us with y plus 8 is equal to 8. Subtract 8 from both sides. And we get y is equal to 0. So what that tells me is that any number, any value of a, will give me a solution that will make all three equations true. Does someone want to give me a value for a? Any number. 2. So we can say 2, comma, 0, comma, well, negative 2 plus 8 is 6. So let's plug it in and check. So it would be 2 plus 0 plus 6 is equal to 8. Well, 2 plus 6 is 8. 8 is equal to 8. Okay? 2 minus 0 plus 6 is equal to 8. Well, 2 minus 0 is 0, or 2, and 2 plus 6 is 8. 8 is equal to 8. And lastly, 2 times 2 plus 0 plus 2 times 6 is equal to 16. Well, 2 times 2 is 4. 0 we can remove. 2 times 6 is 12. And 16 is equal to 16. So the point 206 is a solution for this here. Does someone want to give me another value for A? 35. So we can say 35 is A. So we have 35, 0. And this one here would be negative 35 plus 8, which will be negative 27. So we'd have 35 plus 0 minus 27 is equal to 8. Yeah, and we can do that here in a second. So this here would be 8 is equal to 8. Here, 35 plus 0 minus 27 is equal to 8. Well, essentially that's the same thing with the first one. Even though I wrote plus 0, it really doesn't matter because 0 is neither positive nor negative. And lastly, we have 2 times 35 plus 0 plus 2 times negative 27 equals 16. 2 times 35 is 70. 2 times negative 27 is going to be 54. And 70 minus 54 is 16. So that works. So Kim, what do you want to try? So that would be negative 14, comma, 0, comma, well, negative A, so negative 14 would just be 14, plus 8 is 22. So for our first equation, it'd be negative 14, plus 0 plus 22 is equal to 8. Well, 14, or 22 minus 14 is 8. The next one would be negative 14 minus 0 plus 22 is equal to 8. Well, as we saw in the first one, it's still going to work out 8 equals 8. And the last one, we'll have 2 times negative 14 plus 0 plus 2 times 22 is equal to 16. Well, 2 times negative 14 is going to be negative 28. Plus, well, zeros we can add into it. And 2 times 22 is 8 plus 6 gives us our 4, carry the 1, and 16. So this equation here will define any triple, any ordered pair that will work for all three. So the infinite solution, infinitely many solution can be defined by the set A, comma 0, comma negative A plus 8. And it would give us any value that will make this true. I'm not going to ask you to do this. I wanted you to at least see how we can find it. We're not worried about the baseball problem, but we are done for today. Your homework is on page 38, problems 3 through 5, 11, and 13.